Welcome to this episode of the High Level Podcast. Today we're taking a dive into the fascinating world of wind energy, which has come a long way since the first electric wind turbines, now over 100 years old. Through years of innovation and evolved designs, wind turbines have become more powerful and efficient, positioning wind energy as one of the cheapest and cleanest energy sources available today. In 2022, wind energy accounted for an impressive 22% of new energy installed in the US. And as turbine designs continue to evolve, they're pushing the boundaries of energy output. As we move towards a clean energy future, wind power is leading the charge. Stay tuned as we explore the latest advancements and what they mean for our sustainable energy landscape. And as always, I am joined by my beautiful co-host, Mr. Jonathan Delport.
How are you, Mr. Hunselaar?
How are you?
I'm here with
good,
you, man. I'm here with you, man.
That was the first time I got to do the intro.
And invigorating.
It's exciting, man. I feel like a new person.
You feel like you're killing it.
Yeah.
All right, well, as Mr. Hunselaar said, today we're on wind turbines, right? We're on wind turbines. We're here. This is your episode, so I'm going to do less talking and more listening from the heart, really. That's how I feel today.
And yeah, I believe last week was Valentine's week.
It was.
So I think this is a good lesson for you. Learn to listen.
Learn to listen.
Become
a better person. This is what the podcast is teaching me, to become a better person. That's how I feel. Welcome to everyone in this rainy week in Joburg as well. If you're up in Joburg, my heart goes out to you. It's been a terrible time.
Yeah,
Roads are falling apart. Everything's falling apart. We've got 2% more on VAT, but we're here to teach you about wind turbines.
Yeah.
That's all it is. All right, Mr. Hunselaar, I think the most reasonable place to start is, how did we get here? Where did wind turbines come from? What's the general story?
Well, wind turbines, maybe not in that form, we call them windmills.
Windmills, okay.
But wind energy has been harnessed since the ancient times. We used it to irrigate water, and we used it to ground our maize. I mean, I think like everybody knows about that, you know?
Yeah, I mean, so Jen and I play a game when we go down to Neisner, is whoever can spot the wind turbine first, and then you go, turbine, then you get a point. I always lose. But anyway, yeah. So they've been around for millions of years. Is that what you're telling me?
Yes. Without a doubt.
Go with that. Not misinformation.
But it was first used to generate electricity in 1887. A 33-foot turbine was built by a Scottish professor by the name of James Blythe. And he used it to power his vacation cottage. Typical professor, eh?
Typical, eh?
Typical
professor.
But then in 1931, the first horizontal axis wind turbine, or a HORT, as the young kids like to call it. Those are the ones that are similar today. The first one was built in Talta in Crimea.
Yeah.
And that one was about 30 meters tall, and it produced a whopping 100 kilowatts of energy.
That's not too bad, eh?
Then in 1941, we saw the first wind turbine connected to the grid. And that was in Castleton, Vermont. I think that's in America.
Vermont is Canada.
Yeah.
Never try and check facts on a podcast. Okay, yeah.
And then in 1956, we saw the first modern wind turbine. Those are the ones that classic white tower with the blades that spin around. That was a 200 kilowatt Getze turbine, and that was built in Denmark. That one had 3 blades, and it spanned 24 meters in diameter.
I see, that's quite large.
Yeah, and it included emergency tip brakes, and that's a feature that's actually still used to this day.
Sure, but
To this day.
So
And
Vermont is in the United States. I do apologize. I'm terrible with geography. And there's a Vermont in South Africa. Did you know that?
I didn't know that. But there's a Florida, there's
others. Okay, yeah, sorry, continue.
And then when the oil crisis came around in the 1970s, there was like a growing awareness of like the impacts of fossil fuels on the climate, and that spurred the demand for fossil fuel alternatives.
Okay.
So wind turbines, they grew larger, they started developing new materials, and in 1991 we saw the world's first offshore wind farms, and I believe that was just off the coast of Denmark. So
okay, so
Denmark seems to be the place.
No, they're doing the things, eh? Denmarkians.
Yeah, and now when we talk about like renewable energies, the two main things we're talking about is solar and wind.
Yeah, you'll always see on a chart solar and wind together. Yeah.
So I mean, I think we all are familiar with the concept of generating electricity using wind, but I don't think a lot of people like fully understand how much goes into that.
Yeah.
Because like the one thing about the grid is it has to be at a specific frequency, and wind is not a constant thing. It's not with a coal power station. Those turbines are at a specific speed, highly controlled. Same with nuclear and all of that stuff. But wind is quite erratic, you know. It does what it wants.
When it wants, yeah.
Yeah,
Act of God type of thing.
What's the phrase? You can control your friends, but you can't control the weather.
Is that the phrase?
If it's not, it is now.
Then it is now. All right.
So I mean, why don't we just get into the anatomy of a
I
wind?
think that would be helpful.
So there's a few. Let's see, 1, 2, 3, 4. There's 5 like main components. Some of them have other like components within them, but like there's the 5 main parts. If you can understand that, you can understand wind turbines.
Okay.
The first one is the tower, the thing that holds all of it up.
Okay.
Yeah. So the part that holds the rotor and the gearbox and the generator and all of that's called the hub.
Okay.
And so the tower is what holds the hub between 50 to 200 meters in the air.
Okay.
And so the reason why we want to go that high is because we have high wind speeds.
High wind
Easy
speeds
peasy,
up higher.
lemon
Makes sense.
squeezy.
Makes sense.
Then the next part of the anatomy of wind turbines is the rotor.
Okay.
And that's the big spinny blade things.
The big spinny
It's the
blade.
part that spins.
It's the part that spins. All right. Yeah.
It's generally like 3 large bodies, and it's made of fiberglass. The reason why we go with fiberglass is because it's a light material.
Okay.
And so that fits into a central hub assembly connected to the main shaft. So it's what captures the wind energy. And the efficiency is affected by the length of the blade, the weight of the blade, and the positioning. Hence, wind turbines have a pivoting system. That's a question I had for a while. Because I always thought to myself, like, you know, wind turbines, they need to be able to
turn with the wind.
Like, you want the wind to be head on. So wind turbines have a rotating system. So
makes sense. You know what, for me, is the wild part before you go on, is that if you have a wind farm, all the windmills interact with each other by way of just being there. So you change air efficiencies with the configuration of the wind farm. That's so cool. I love watching those videos where they do the CFD through the mountains and stuff. But anyway, that was just interesting stuff. All right, then we move on to the generator.
Yeah, the generator. So the rotor connects to a low-speed shaft and a gearbox, transfers that motion to a high-speed shaft. So those blades generally don't spin very fast.
Yeah.
I mean, like, otherwise it's like a giant helicopter on the side. Like,
yeah, not a good thing.
That would be pretty scary. Like, I think if I lived underneath a wind turbine, I'd always just have this like fear that like
It's
one of the
gonna
blades would. Obviously, they're highly engineered. So
Fair. We trust them engineers, but also, I mean, if the thing's going 200 RPM next to your house, that can't be very nice.
exactly. So they generally
Got you?
They'll put a gearbox on, and that will turn it from a high torque low speed to lower torque high
Higher
speed.
Okay.
And some of these like gearboxes can weigh up to 15 tons. And
15 tons
15
at 200 meters in the air. That's horrifying.
Yeah,
man.
that is.
Okay.
So you can imagine like maintenance is a bit of a bitch. And so
This is a nice word.
there are some experiments with like direct drive. So that's when instead of having the shaft into a gearbox into the generator, there's a direct one. But they have to play with the poles, the magnetic poles on the generator to get the frequencies we're looking for.
Okay,
so,
got you.
I mean, that's a very interesting one. Then you get the part that's called the nacelle.
Nacelle?
Yeah, I wasn't sure how to pronounce it, but I heard it on a video. So now
We're going with that. Okay.
and that's basically, it houses the shaft, the gearbox, the generator, and the brake.
Okay.
And it also contains a device that adjusts the rotor pitch, because that's one of the ways they control the speed. So they can
Change that
like
angle of attack.
basically.
Okay. And so that's that little coney part, if you look at a wind turbine, like in the middle, that covers the gearbox and everything,
Exactly.
at the top. Okay, got you.
So it's just basically the fancy word for the housing.
Okay, got you.
And then you get the controller. So the controller will monitor wind speeds, and if you get the wind speeds between 8 to 16 miles an hour, then it will start then it's fast enough that the wind can generate electricity, and then by different means, by either braking it or by adjusting the pitch, then you can get like a constant rotation of it, depending on the wind speed. But if the wind speeds go up to about 55 miles an hour, I think that's around 80 kilometers an hour, then it will actually turn the wind turbine off, because at that point it's getting a bit
Rotating
dangerous.
too fast. Okay. So that below 8 miles an hour, they also don't allow it to turn, or it's just too heavy to turn.
My guess is that it's too heavy to turn, so you're not
even
going to
if
get efficient
Okay, got you.
transformation.
All right, cool.
So yeah, I guess the big question is why do we even use wind energy?
Why make use of wind energy?
Yeah,
Mr.
so
Antelor? Come on.
the International Energy Agency has identified wind energy as a key element to reduce fossil fuel dependency, and it's a helpful tool in combating global warming.
Okay, fair enough.
So the worldwide greenhouse gas emissions in 2021 was roughly 54 gigatons of CO2 equivalent. So that's all I mean, we've spoken about this in the past.
Yes, no, we've done this before.
And it's projected to reach about 70 gigatons
Yes,
by
yeah.
2050. So obviously, as a response, the world did that whole climate change
Paris Agreement type of thing, yeah.
So
okay.
and wind turbines are considered like one of the components to
Like a
move
big
forward.
part of
I think
how to
a
move it.
common thing we say on the podcast is this isn't the only solution.
The
It's
silver
part of the
bullet.
problem, and again, wind turbines are part of it.
Yeah, 100%. So I have a few problems with wind energy. I don't have a love for wind energy. I think you know this. I'm not a wind energy fan. I go in and out of love with it. I don't think it's a nice technology. I'd rather put a solar panel up. But I think let's discuss a few of the problems that we commonly come into contact with wind energy. And so yeah, you put these down. What are we looking at here in terms of problems when it comes to wind energy?
So we're looking at what are the challenges we face. Like, because let's face it, as much as you maybe dislike wind turbines, I consider them to be a marvel of engineering.
No, man, come on.
Come on, man.
Come on, man.
Maybe it's just because they're really big.
Okay, no, fair, yeah. But man, come on. It's 3 blades. Turn around.
Yeah, but it's
Come
also 15 tons in the air.
Okay.
Like, suspended.
A little bit, yeah.
Yeah,
No, good engineering. But
Yeah.
anyway, we can get to my feelings later.
Yeah, so there's obvious design challenges when we're looking at turbines, because there's a lot of research going into the blade design. So
Yeah.
whether that's materials or that's the aerodynamics of the blade and how to control that, there's a lot of research into that.
Yeah,
I don't think it's the
simulations and
biggest
things.
challenge. It's just like the first thing.
Yeah, no, 100%. There's always design challenges.
Exactly.
Right? I think I still remember who was jet engines and stuff in varsity. Werther?
Yeah.
And he told us that you can't spin a wind turbine more than I think it was 70 RPM, somewhere low there, like 50 to 70 RPM, because if you go any quicker, the tips of the blades become supersonic and they start to melt. So it just shows you how much torque and speed and stuff we're working with.
Yeah, like it's not rotating fast, but when you consider that it's 12
it's
meters
at a
away
radius.
and
Yeah,
now
yeah.
it's
And some of the blades are massive.
Yeah,
So
I
yeah,
know.
no, big.
I don't know if you've ever seen
big
like
forces.
one of those videos of like a truck.
Yeah, and then
carrying a blade, and then like you
it's
have
like
two
different
trucks,
and oh my
and then
word.
like when they get to a corner,
It
that
just
to be
looks
a
terrible.
whole,
Yeah.
So that brings us to our next challenge.
Yeah.
And that is like location issues.
Yeah.
So wind turbines need a lot of space.
Massive amounts of it.
So you can't put, because they require large areas, and the first obvious capital challenge is someone needs to own that land. So if I want to put a wind turbine somewhere, I can't just go and put it there.
Yeah, no,
I
100%.
mean,
Yeah. You have to pay them a royalty.
so
or
I either
rent
need to
or-
own the land,
Yeah.
or I need to pay someone a license or a permit or something to say, okay, yes, I can put my
put this thing. Yeah. No, 100%.
So like wind energy farms are usually located in like rural areas where there's a lot of land
Yeah.
availability.
Yeah, 100%.
And another thing is the power depends on wind speed.
Mm.
And if you're in like a highly populated area with a lot of buildings, that acts as like a dampening on the wind speed.
Yeah.
So you don't get a lot of efficiency.
100%.
And yeah, so then the next challenge we face is variations in wind speed. So the other ones,
Common problem, I would
Yeah.
think. Like this must be a terrible thing to deal with.
yeah. So with wind energy, you don't get a lot of energy availability
Okay, explain.
because you can't control the weather.
Okay, good. So you can't basically say we're going to have good wind at 12 o'clock type of thing.
Exactly.
Yeah, okay, got you.
Yeah.
Okay.
And interestingly enough, the best winds for wind turbines happen at night when there's the lowest consumption. So that's another challenge with wind energy.
Is that like the temperature change? Something happens. Why does more wind blow at night?
I don't know.
I
But
know
if you are
A meteorologist or
then let us know.
a weatherman. Maybe just let us know. Why the heck does wind blow stronger at night? That would be interesting to hear.
Yeah. So now, because of this wind speed variation, it's very, very difficult to get the frequency, the AC output frequency, to match the grid.
Yeah.
And so you need more infrastructure that lets you regulate all of that stuff, and that also becomes a challenge.
Yeah. I think a lot of, just to stop on that point, I think we've spoken a lot on this podcast about voltage and maybe current draw. Frequency is not something that gets brought up a lot, right? In terms of discussing renewable energy and where it's good, where it's not. Especially in this case with where you say, like, the wind's not constant. We all know that. So it's very tough to regulate the frequency that you're getting out. And I remember this, we were discussing earlier. There was the shutdown, I think it was in Texas last year or the year before, where they almost had their grid fall apart. And it was because it was off by like 1 hertz. And I think, what do we run in South Africa? 60 hertz. So if you off by 1 or 2 hertz, it's not like a little problem. Yeah. It's a massive problem. The whole grid can go down. So an important part of the grid that should be discussed more, I think. Right? Agreed?
Yeah, agreed.
100%. All right, what's your next point here, Mr. Hoons? Last year, last table.
The next challenge is damage to the environment, because a lot of people think that there's not
the birds.
But where is the justice?
The birds. Where's the justice?
For the birds? Because, birds, I mean, there's a reason why they say bird brain. When you need to jump some of that.
Are you making a statement that the birds deserve it? Is that what
I'm not saying they deserve it.
Okay.
I'm just saying they're not very clever. I mean, they see this big spinning thing and they're like, it is
Let's
time.
just go. It is time.
But if you actually look at the numbers.
Yeah. I like to look at the numbers.
If you look at the number of kills of birds per year.
Yes.
The number one rating is actually cats.
Cats. Okay, so cats, you're telling me cats kill more birds per year than wind turbines do?
Yes.
So why
That's
are we not...
about 1,000
compared to...
million birds per year.
1,000 million?
Yes.
Number of birds per year in millions. So cats kill 1 billion birds a year?
Roughly. Yes.
What the F? Okay.
Then the number 2 on our list is buildings, which is 100 million.
Okay, what are we to do about that, man?
Yeah,
if you can't see the thing that's standing still.
I mean, I think everyone has a memory of just sitting somewhere and then a bird flies into it.
Yeah. 100%.
And matching buildings is hunters.
Hunters.
So why even go hunting if you want to get birds? I mean, put a building there, you'll kill just
as many birds.
Statistically.
It's just maths.
Then vehicles is about 60 to 80 million. Pesticides is 67 million. Power lines is 0.01 million to 174. Varies a lot.
Yeah, a little bit, eh?
I'm assuming that's because of region.
Yeah,
it depends
probably.
on the region.
Maybe they just.
And then on the list, we get wind turbines, which is about 150,000 birds a year killed by wind turbines.
Seems insignificant compared to the cats.
Seems insignificant, but you also got to remember that as we put more wind turbines up, chances are that number will rise. So,
can we get rid of an equivalent amount of cats to balance it out?
I mean, we can. I just don't know if you're really helping.
Okay, not helping the cause.
The
okay, no, fair enough. Okay, so by the numbers, not too hectic.
Yeah, not too hectic. And it's also not like people are aware of it, because you get aviation radars in Texas. They use avian radars to detect flocks of birds, and when they notice that a bird's about to fly into the wind farm, then they'll actually shut it down, let the birds flash through, and then start it up again. I mean, there's the justice.
I don't know if I'm for that.
I mean, at that point, it's probably closer to the building. So I would say you're causing more harm there.
Fair enough. So you don't get rid of the problem completely.
Yeah.
But fair enough. In terms of, I would imagine that having, let's say I'm in a residential neighborhood and they put up a wind turbine, I would assume that's quite a noisy thing. Is that a thing? Is it noisy?
Yeah. So wind turbines are quite noisy.
Okay.
And having it in your area, it can reduce the property value in a certain radius.
Really?
Yeah.
Oh, shit.
And and it can be loud enough that it can be hazardous for humans.
Hazardous?
Hazardous, because
it causes hearing problems and things.
Yeah.
Probably.
So
okay. Well, I guess it's noise pollution. So
there's a nice little graphie over there.
Yeah,
that I saw the same graph in a couple of papers that I was reading when I was researching this. So this graph shows the noise level dBA L90. So they use the L90 metric. What that means is that 90% of the time the volume is above this level.
Okay, got you.
So if you look at that graph there, you can see it's about around. So the thick black line is probably what they measured at the time, and then the grey line is like a moving average.
Okay, got you.
So we're sitting at about.
Is the right hand side
30 to
decibels?
40. Yeah.
Is that right?
Yes. Yeah. Remember, decibels is a logarithmic scale.
Okay, got you. So the gap change between 0 and 10 is the same as 10 to 100
I think so.
in terms of rate of change.
Yeah.
But anyway, it doesn't matter. It's still like
I know
around
90 decibels is considered bad.
and 40.
Yeah.
What is a decibel range of a 40? What would that be to me as a layman?
Sound engineers, if you're listening to this, let us know.
Let us know what this is. All right.
There's a lot of wind turbines. Like you take the train and you just go through.
You just see them.
You just see them everywhere. And like to me, I found them quite mesmerizing. Maybe the people there are quite used to them, so they don't.
Yeah, maybe you get over it.
Maybe you get over it. But for me, I was like, that's cool, and yeah. So, but a study found that in general, stationary wind turbines are considered uglier than moving ones.
Why?
To me, I would think, if it's stationary, it's
Speculate
not
for me.
working.
Yeah. Oh, got you. Now I have this ugly thing. It's not even working.
Yeah.
Okay, got
And
you.
then another thing is people want like uniformity. They don't want two or like different sized wind turbines. If you're gonna have this type of wind turbine here, don't put up different ones. Like they must all be the same. You know.
Fair enough.
I think that's just unique. And then another thing is the like shadows of the wind turbines. It bothers some people. And the sun also can reflect off of the surface. But that's
You see, that would F with me.
yeah.
I would hate that.
But that's mitigated by looking at the coatings to get something that's not so reflective, that's
Some
maybe a
better
bit more
paint.
dispersive. So
Okay. I've got some decibel ratings for you, yeah?
go for it.
A 40 is the same as a quiet residential area. You go up to 70, that's freeway traffic. And then if you go up to 90, that's a truck. If a truck had to drive past you. Those are general metrics if you wanted a baseline. Helpful. All right. Anyway, continue on, Mr. Unsadal.
Yeah. And then the next challenge when it comes to wind turbines
I think this is a tough one.
is the capital investment. So most of the capital investment is when you actually build the thing. Afterwards, it's not that expensive. So there's 3 categories. There's your fixed or capital costs, then your variable costs, and then your costs of generation.
Okay.
So if we're looking at fixed or capital costs, that's going to be your road to construct it. You have to lay down cables to
Your
get there.
civil
Remember,
works.
we're building these things in rural areas.
Yeah.
So you've got to lay a cable
of
from there.
infrastructure.
So yeah, it's very
I think also just because the nature of the beast is like wind is in locations that's difficult to get to, right? Like it's in mountain gorges and things and stuff like that, or large open areas.
Yeah.
So like there's going to be infrastructure you have to put in. There's no
Yeah.
getting away from it. Yeah.
Yeah, so I mean, if you're looking at your variable costs, that's going to be things like your operational management, management of the system,
Labor.
any like land. Like if you don't own the land, you have to rent it,
Yeah.
insurance, and all of that stuff.
All
and
of
then,
that fun stuff.
And then your generation costs are like wind availability. So if there's not a lot of wind, then your wind
You're
turbine-
paying for that.
You're paying
Yeah,
for that
yeah.
because you've built this thing and now it's not generating electricity.
Lost revenue.
So
Yeah.
lost revenue. And then again, the lifetime of the
Yeah, things need to be maintained.
I think I
So-
saw somewhere that that wind turbines are generally designed to operate for like 20 years, but on average they only operate for about 7 years before they
Why?
start
What's
to get
the
problems. The main
bad
problem
maintenance?
is reliability on the gearbox.
Ah,
the
of
oils are there,
course.
like
Look at that.
mechanical failures.
Guys, if you're looking for some consultations, we can help you out. We can
Yeah,
help you
just
out.
reach out. We can
Just reach out. Just reach out there. Okay, sweet. So yeah, high capital cost. I could see that. Maintenance cost. I mean, there's not a lot of hectic moving parts. Sure, there's a lot of torque on the rotors and stuff, but I mean, as long as you maintain it, should be all right.
Yeah, but also another thing to consider is maintenance is not so simple because now you've
True.
got to send someone up there,
True.
and that's a work
It's a very dangerous environment.
to be in.
Yeah, 100%.
And I don't know if you've seen pictures of when they like decoupled the hub.
No, I've never seen that.
Sure.
Is it rough?
That's terrifying.
How did that with a crane or how do they do it?
I think it's got some other things that lets it do that, but
Okay.
it's terrifying, man. It looks like it's about to fall off.
Oh my gosh. Can you imagine trying to handle something? And I mean, if the gearbox is 15 tons,
And if something catches fire while you're up
oh, you're dead. Dead.
there, dead. So
Dead.
yeah, no.
Okay, another thing I would think is like when you come to end of life now, since you said like most of the blades are made of composite materials, fiberglass, carbon fiber, whatever, I would assume hard to handle. True? Not
Yeah.
true?
So the tower itself is relatively easy to deal with.
No, it's
Because
steel.
it's structural steel that's generally used to use that, so it's easy to do that. But the problem comes with the blades, because they made from like a composite fiberglass. And materials vary, but
Yeah.
it has to be lightweight and strong.
Yeah.
And generally that's very difficult to recycle. So that becomes a problem. So now,
Why can you imagine if we're building thousands of these things around the world and average lifetime is 7 years? Like, it's going to start being a problem at some point. Like, you can't just throw fiberglass away, you know? It's a tough thing to recycle.
so it's going into landfills. And like some of them you can put into like other wind farms maybe,
Yeah.
but that's not always the case. So I have this graph here. I just want to zoom in.
It says by region.
Material
in
generated 1,000 metric tons. So that's that graph over there, that blue one with the gray at the top. That's the estimated waste that's going to be produced between 2029 and 2049
Gee whiz, man.
from just like the blade material.
And you check out, it just climbs exponentially.
Yeah, so it's 1,000 metric tons. So you got to multiply it by 1,000.
Yeah.
So in 2029, they're estimating that the US will be at like 14,000 metric tons, while the rest of the world is sitting at about 17,000. EU, because EU are big on like wind energy and renewables,
Yeah.
they're at 89,000 tons. But by
It's crazy,
2049, they're estimating that the US is going to be, I think that will be about 1 million metric tons.
Of material that's very hard to recycle
Yeah.
if you want to. Which we all know, if it's hard to recycle, they just throw it in landfill.
Yeah,
So-
and this is cumulative, so it's not per year or anything. It's over the time.
Yeah.
And then with the rest of the world, so I think with all of that together, you're sitting at about, so that's about 1, 2, 5. So that's about 7 million tons of waste.
Yes, man.
But-
That's crazy.
And those numbers are big.
Yeah.
But like with everything, you got to look at it in
Comparatively.
context.
Yeah.
Comparatively.
Yeah.
If you look at the greenhouse gas emissions of like CO2 and oil and those things, you'll see that wind energy is very low on that scale.
Yeah.
So while the waste is a thing, and like we're not saying it doesn't produce waste, it really that amount of waste doesn't hold a candle to what's being generated
what
with
would be
coal
done
and your
with coal
fossil
and
fuels
oil
and all
and
of
stuff,
those
yeah.
things.
I think it's
So
to virtue signal. Like you say, we're not saying it doesn't matter. We're saying it does matter. But look at the alternatives. What else are you going to do? You still need electricity somehow, you know?
Yeah.
Flip, if you're going to solar panels, you also have to recycle the solar panels after 20 years. So again, like you say, it's comparative. We've got to look at the whole picture.
Yeah,
And when you look at the whole picture, not too bad. Not too
And
hectic.
look, once the wind turbines are up and running, there's no emissions.
Yeah. No, like you
It's-
just carry
it's
on.
getting, like we said, most of the
Getting
costs
there.
and the problems are
Getting to
building
that
it.
point. Yeah.
Once you're there, you're there.
Yeah, 100%.
Yeah. So another really interesting thing I want to talk about.
Let's do it. Please,
is
take me
called,
into this.
and this takes us back to our frequency thing,
Yes.
where we said that, okay, when you have a power system, and okay, we're not power system engineers.
But we will be for today's episode.
Yeah, but we will be. So there's a very important concept called grid inertia.
Yes.
So that, in a nutshell, is how well is your grid guarding against change in frequency.
Okay.
So, and it's a very mechanical thing actually, because, and maybe that's why we're qualified to talk
There we
about
go.
this.
There's mechanical things
Because
involved. We're here.
it's a mechanical phenomenon. So if you think about like coal turbines and most like power generation things, it's a big ass turbine, big metal bladed disc thing that spins really fast.
Yeah.
That doesn't want to stop spinning. So if there's a problem in the grid with the frequency, that mass is going to compensate for that.
Yeah,
So it's going to
100%.
regulate itself. So now, we mentioned earlier that wind power doesn't quite have that ability.
Yeah.
And that's because we have to first convert that generation into DC,
Okay.
and then use an inverter to turn it back into AC, so that AC will be like a constant power generation. Now, if that gets hit with frequency fluctuations, then you don't have that grid inertia to mitigate against that.
Got you. Because it's electronically controlled, basically.
But people much smarter than myself have come up with a solution for this.
Okay.
So they're saying if we're not going to have a big spinny turbine to do this, we're just going to put in a flywheel underground. So in Ireland, they're converting a lot of the old coal plants into facilities that have big flywheels underground. And especially when there's excess energy being produced by the wind power generation system, it brings this flywheel up to speed.
Up to speed, yeah.
And then they use that to compensate for the grid inertia. So I thought that was really cool.
It's awesome, man.
I think Ireland has about 5 of They trying to build
And
5 or they have 5.
I think it's like 200 tons or something, isn't it?
Yeah.
It's a massive thing.
Yeah.
It is a massive
You
thing.
definitely don't want to touch it. While it's like,
Or be anywhere near that.
So-
I think it's even in a vacuum chamber, if I'm right.
yeah,
I'll do
because
some Google.
it's meant to store energy. So
some
if you
Googling.
don't keep it in a vacuum, you're going to get losses there.
Yeah.
So yeah, I think that's pretty much the challenges that we're facing in wind energy. So after talking about these, has your opinion of wind energy changed?
No,
all?
I hate wind energy.
Why?
I hate it, man. It just seems inefficient. Anyway, this flywheel is 120 tons of pure metal amazingness. That's amazing.
That's cool.
120 tons. I don't like wind energy because it's inefficient to put in. You do it in the middle of nowhere. Fair, you do the same thing for solar, but I don't like it because it has so many moving parts. It looks dangerous to climb up there.
It is dangerous to climb up.
Am
there.
I biased? Most probably, but I don't like it. I feel like it's a waste. I don't enjoy it. I'd rather put solar panels everywhere.
And what about places that don't get a lot of sun, like most of Europe?
Fuck them. Yeah, fuck
You
the
heard it
rockfish.
here.
You heard it here.
Okay.
All right, so I think let's get to the real meat of this episode, Mr. Hutzler.
Yeah.
Explain to me what a fish has to do with a wind turbine.
So this more applies to like vertical wind axis turbines.
There are other.
Yeah. So the ones
Vertical?
we know are the
horizontal axis.
ones.
Okay,
But
got
you
you.
also get vertical ones.
Got you.
So what researchers did is they studied the vortex shedding of fishies. So when
fishies.
so when fish swim, they hit the water and that causes a vortex.
Got you.
And what they found was that schools of fish generally swim in a certain formation that optimizes the dissipation of those vortexes and thus increasing their efficiency. And when they applied this to vertical axis wind turbines, they saw that just by arranging them in a specific way, you got more efficiency from your wind farm.
That is wild, man.
Just by watching how the fishes swim.
By watching how the fishies swim.
Yeah.
It just shows you how much we have to
I'll
do.
leave a link to that the paper that I read that if you guys want to read more about it. I thought it was very cool. It's just a good example of how when engineers look at nature to solve problems
How
and they find
magical.
solutions to these things. That's what I really like about this. It's a completely unrelated thing, but when you look into it, it's got applications for
100%.
wind turbine efficiency.
And it's so simple as well. Like, what a cool thing, actually. I wonder how someone came across that. Amazing. Alrighty. Can we finish off with some wind statistics for South Africa?
Sure.
100%. So we are South African dudes. We like a bra, and we're going to bring it back to South Africa right now. All right. So I've got the common graphs for you from Stellenbosch University. These are the bangers that we get. Still highly dependent on coal. Believe it or not.
Surprise.
Surprise. All right, current wind infrastructure makes up about 5% of our energy supply. So, I don't know, that's actually higher than I thought it would be.
Yeah.
It's higher than solar, which is interesting. But anyway, about 5%. You see that little mappy on the right there?
Yes.
So that mappy shows you where the good wind is in South Africa and where the bad wind is in South Africa. So, Western Cape.
Along the coast.
Along the coast, as you would suspect. Gauteng there, a bit of blue. Blue is bad in this case. In this graph, blue be bad, not very good. Green be okay. But I think takeaway from that graph is most of the wind farms are going to be along the coast. Western Cape, Eastern
Makes
Cape,
sense.
KwaZulu-Natal. Makes a lot of sense, right? And maybe some offshore stuff. Who is to say? Then, these ones are interesting because these come back to your capitalized cost when you're building a wind turbine. So there, on that left graph, production and global costs. Do you see said graph, Mr. Hunselaar?
Yes.
Do you see wind cost is the lowest of the costs?
Yes.
Do you see that? So wind is actually fairly
Cheap.
simple to erect. Yes, I am a 12-year-old child. Fairly simple to put up, even compared to solar. So I still, this is the only thing that really gets me by wind, is that for some reason it's super cheap to put up, even when compared to solar, which is awesome. Capacity, you'll see there on the right, also wind and solar pretty much on par, doing pretty well. We got a kilowatt per ZAR, levelized cost of ownership there on the left. So you'll see there, also fairly low, man. I think that's about 1 rand per kilowatt hour, call it, solar and wind. So not that hectic, as a levelized cost of ownership.
So I'm just looking a bit closer at this graph,
Look
and
at
I
that.
see that. So the line is the cost,
Yeah.
but the solid thingy is production.
Is
So as
production.
costs are going down, you're getting significant production.
Yeah.
So
100%. So wind and solar, as we've seen over the past few years, are doing so well. Just in terms of how, I don't even know what the reason is, man. I think
costs
the
are going
Chinese.
down in production.
I think the Chinese have really upped production. It's driven costs down. It's
What's
getting really
CSP?
competitive. CSP is concentrated solar. So it's that thing where you put a whole bunch of mirrors that shine up to a boiler. So, no, CSP, terrible. We should probably do an episode on that. Worst solar technology ever. Worse than wind turbines. Worse than wind turbines, I'll give you that much. Last one I want to look at there, that bottom left graph, that day energy production. So what's nice about wind, and I'll give it this as well, very consistent supply to the grid. Like you'll see there, solar, again, we did the solar episode, very concentrated in the middle of the day, and then you have to figure out a way to store some of that excess stuff for the night. Wind, fairly constant, especially when you're looking at summer versus winter and things like that.
This contradicts the point I was making earlier about the night.
Well, I think it would still. How does it contradict that?
Because
night?
we're looking at like the earlier.
Yeah, but I mean, you got to look at the thickness of that graph. It's not.
See the.
You see, it's percentage makeup of the total.
Yes.
So the thickness is pretty telling. You can see there from like 3 o'clock until midnight. It's pretty good. So yeah, and then I thought, just look at the pipeline for wind projects in South Africa. There's actually quite a lot, whether any of these actually come to fruition or not. So this graph on the right, I'll give you this, is very confusing. It took me long to understand it. But I just want you to look at that bottom PC there.
Okay, the colorful one.
We're going up there to 2020. Is that 2026? I can't see nicely. My eyes are terrible.
That's the middle one.
The middle one showing you that we're peaking at about, is that 5,900 wind projects, the light green blocky?
Yeah, 5,900.
So 5,900, that is supposedly, this is from an ESCOM report in 2023, supposedly individual projects that will come online or start being built as wind farms. And then the dark green bars are wind plus battery storage. So there's a big pipeline for wind in South Africa. And I guess there are smarter people than me out there saying that wind is the way forward, so I'm not going to be a cunt. Like, I understand they probably know more than me. I just have my biases, and I acknowledge that.
Look, I mean, let's be real. I think, especially in South Africa, I mean, for Europe, wind makes sense.
Makes a lot of sense, yeah.
But I think in South Africa, solar just makes so much more sense.
Yeah, but even look at the graphs, man. It shows you wind is doing well.
Wind is more consistent.
There's more wind. There's more consistency, lower cost, lots more production. I don't have the answers for you. I just have my opinions. What's your final opinion since you are the wind expert of this podcast?
I like it, man.
You like
I
it?
like wind. I think
100%.
it's cool. But, I mean, I think in South Africa, I think solar's like a better option.
You think so?
Yeah.
I think, again, like we always say, it's going to be
Part of the solution.
It's going to be part of the solution. So we're all running the race together. Like you saw inland, there's just no wind. So that's going to be a better place for solar. At the extremities where there's lots of space for wind, put the wind in. Why not? I mean, we're all here for the same goals.
Yeah, especially if there's not a lot of birds.
You know, no bird. Or if you want to kill off the birds. You know what I'm saying?
Yeah, then just put a building there.
Put a building there with a
some
cat on
cats.
it. And we're there. All right, that's the episode then, Mr. Unsalar. You want to hit recommendations, or do you not have recommendations today?
I've been watching The Mentalist a lot. So
The Mentalist. You're getting back into it. Well, did you ever watch it before this?
Well, I mean, I saw it a few times on SABC, but like recently I've like committed to watching the series.
Okay, how far are you in?
I'm in the beginning of season 4. I've been watching it for a couple of months already.
Gee whiz, man, that's pretty
That's good. It makes you feel like you can read people, but like also sometimes I'm like, who would fall for that?
Who would fall? Do you think you could be hypnotized?
I don't know.
I don't know.
I think I'm
I
too.
will not be hypnotized.
I'm too. What's the word like?
Skeptical.
I think if someone tried to start hypnotizing me, I would. My go-to reaction would be this oak's full of shit. I mean, like,
So you
a
wouldn't
lot
be
of the
open
time
to
when
it?
people are like talk to me and I think they're talking shit, I'm just like, oh, this oak's full of shit.
You know what I think why you wouldn't be hypnotized? And I've had this consistently with you for the past few weeks, is you just don't concentrate on what the hell I'm saying. So they could never get you to look at them for long enough to be involved in the conversation.
That's a you problem because you always try to get my attention when I'm busy with something.
Okay, fair enough. Fair enough. So I've been watching a few sports documentaries. So watched The Last Dance, very good. Michael Jordan documentary, very good. Would recommend. And then we started watching Drive to Survive, Formula One. Very cool. Lots of drama. I'm actually loving it. It's like my reality TV show. Loving it. So yeah, I would recommend. Is that all from you, Mr. Unsalon?
That is all from me.
That is all from you. All right, guys, thank you so much for watching. We really appreciate you. If you want to get into contact with us, it's highlevelpodcast@gmail.com. And please hit that like button, hit that subscribe button. We really appreciate it. You guys help us out so much. And that's the episode. Any final parting words, Mr. Unsalon?
In these dark times, be strong.
Be strong.